All right, before much ado, let's go ahead and get moving. So I'm going to go ahead and close up some loose ends, tidy up a few loose ends that have been kind of left behind. Um, One of them is to go ahead and select connectors and kind of tidy up some of the things with some of the other circuits we've already established. We're going to have to do it eventually anyway, so we might as well just go ahead and take care of it now. Kind of move this a little bit further to the side. So one of the things we're going to want is obviously a connector. Multiple different ways we can go on this. We can go with screw terminals, but I like pluggable connectors where you can have an actual removable connector that we don't have to unwire anything if you want to swap parts or pull the system out, whatever. So I've already got a pluggable selected that I like. Um, it's a 5 millimeter pitch Euro style header, and I got its mated connector. So what we're gonna do is what's interesting is so Mauser does not offer the footprint or the um, schematic symbol, which doesn't really matter for something like this because it's just going to basically be a couple of pins. We can copy an existing symbol for that. But what I went ahead and did to save some time, found the same two-position header on DigiKey, and they do offer the footprint and a 3D model for it. So we're going to go here, KiCad 6 Plus. We're going to get a step file, and we're going to go ahead and download it. Close. We're going to go and go to the downloads. I still need to clean up the zip files. Crazy, crazy. But we'll get it eventually. Okay, we're going to right click, extract all, bam. So we have the KiCad, we have the footprint. Don't really need to worry about the symbol too much because, like I said, we're going to cut, and we got the step file. So this is going to be the same lather, rinse, and repeat. We're going to kind of do something a little bit different with creating our connector. So let's go and start the footprint. Let's go open up the connectors. We're going to File, Import Footprint. Downloads, we've got here. Open. All right, so we're going to go and move that here for now. We can change it on the board. Let's just go reference. So it's going to be, we're going to call the reference for these, we're just going to call CNs for connectors. Now, the easiest thing to do, let's see here, pin 1, pin 2. We got pin 1 designator on the silk screen. That's fine where it is for now. We can always fix it later. Can we change this to a whole circular? Let's see here. Whole shape. A lot of times you designate rectangular. So a lot of times pin 1s are actually designated with a square pad versus a round pad. It's just easy to identify if you're looking at the board. So I went ahead and just double clicked on the pad and dragged down to rectangular. It kept all the sizes, which should be more than sufficient. Nothing will cause interference. We're going to save it. Now, we want to save it since it's pretty much for this connector. We're going to copy the part number for the connector, put that for the part name to connectors. We're going to save that. We're going to go ahead and get the 3D model pulled in. Let's get this done. Oop, there it is. Oh, lovely. It's going to be a lot of fun. So let's see. X-axis, we're going to have to do 90. Looks like up and down doesn't have to go, but we have to offset X and then Y. Again, just 3D representation. It just helps if, again, if you ever have to, 9.5, point, 9. Yeah, let's just go and do that. Again, it's just a 3D representation, no big deal. So we've got our footprint in there. Let's go to symbols, our connectors. That one, what we will do is we will go ahead and duplicate that, rename it KP for connector pluggable, the Molex part number from Mauser. We're going to copy that. We're going to go to File, Properties, Footprint. We're going to go ahead and fix that real quick. That way it matches there. Okay. Now, okay, description, connector, home. It's not really a header. Technically it is, but I like calling it a pluggable. Did I spell that right? Probably not. Technically, what would be a receptacle? Receptacle. It's 2-pin, 1 row, right angle. It's a through hole. It's going to be a 5mm pitch. Oh, pluggable. Let's just go on pluggable. Pluggable. And it's what, 5mm? Yeah. Let's just go to pluggable. 2-pin, 1 row. So technically not 2-pin. 2-circuit, right angle, through hole, 5mm pitch. Don't really need this. Okay, and its temperature range are not listed, so I'm not going to worry too much about it. I could probably pull it from the data sheet, but not terribly important. Not going to worry about it to save time. It is Molex, which is kind of cool. Get the manufacturer part number. It's going to be Mauser, and the cost 31 cents. We'll have to figure out. All right, and the high volume, there's no real 100 quantity value, so we're just going to go 308. I mean, we're not really going to save money, but all right. So for a connector, we're going to add another value, and we're going to call it mate, because I've already selected the mating connector for it. And we're just going to copy this. Show name. Okay. Before I okay, we got to do the typical thing we do with Odo. It's again, lather, rinse, repeat, lather, rinse, repeat. Sale, purchase. Don't. I think I could. Are you kidding me? I hate that. Oh, you stupid key, mouse. I'm gonna have to disable that key. Button. 31 cents. Category. I think I have connectors already. Reference. We're gonna pull from here. Purchase. Mauser. One. Upload. Now in Odo, we're going to go ahead and create the mate for it. That way it's already. Shoot, did I? Hopefully I did not copy and paste the wrong thing. Okay. We're gonna go ahead and put the mate in. Go to new. KP. Mouse out. One, and its cost is $1.42. General information, good. So you go under connectors as well. This is going to be pluggable terminal block. Circuit angle. Screw terminals. Actually, I should have added more information into the other one, but that's fine. Let's see. 300 volts, 18 amps. All right, let's get the 12 to, or 26 to 12 AWG. That is important. Make sure I have it. Yep, 26 to 12. All right. Yep, that way, at a glance, we can grab our wire diameter. 9 volts, 18 amps. Pretty hefty guy. So we're going to Alright. Make sure that we have all those part numbers the same. 39500. Alright. Alright, you know what? Okay. Three 95002. 2002. Make sure that all there. Okay. Let's go into this one. Let's go in through the 300 volt 18 amps in there. Yep. let's go ahead in here. Okay. Yeah, it's going to, yeah. All right, let's save that. Back to our power supply. We're going to drop the pod in, connect those. All right. Throw that guy in right here. Wonder if we can. There we go. Let's do this. Ah, perfect. There we go. So we have our mate. Let's go ahead and kind of move you down here. Move you here. You know, let's move that down here to the bottom too. What the heck? Now, while I'm sure there are other pluggable blocks that can actually mate with this particular connector, we're just going to go and choose one for our own benefit. That way it's permanently with the schematic and we don't have to fight it down the road. So let's go move this guy here. So one of the things we also need to consider is so we don't need the 2-pin anymore. So we can go back here. So I've already kind of selected the 3-pin for the RS485 connector. We'll deal with that later. I had that later because one of the things I want to go ahead and take care of while we're here is the blocking diode to basically help limit our chances of accidentally wiring everything backwards. So we're going to throw in a Schottky diode. So let's see here. We don't need ESD. We need a just a diodes and semiconductors. Discrete semiconductors. So you want a good Schottky diode. Let's see here. Diodes. Schottky diodes and rectifiers. Schottky is typically what's called a blocking diode. So we're going to do SMD. Apply. All right, let's see what we're looking at here. Let's see, forward current. We'll worry about that. Repetitive reverse voltage. So we want to be able to reverse basically, you know, at least 24 volts. Though if I'm not mistaken, let's see, the power supply can handle up to 32 volts in. So let's repetitive voltage. Let's see what we got. 260 for 50 volts. How about let's say 60 volt. All right. Okay. Let's see. Forward surge current. We wanted to build at least handle. Let's see, around maybe 5 amps. So we got 3 amps, 8 amps. We don't need anything extremely chunky because we're only looking at about 2.5, maybe 5 amps. Yeah, let's see what we got. Very low forward voltage. All right, so let's see what our continuous current can be. That's 1 amp. Oh no, we want our let's get rid of our surge current. Let's go forward current. Let's see here. We want at least 2 amps because the power supply is rated at 2 amps. Although, since it's a switching power supply, it's typically going to be half of that, so 2 amps should be more than sufficient. Okay, that pushes our forward surge current up, which should be more than fine. Let's see what we got. 38 cents. That's Diodes Incorporated. Vichy. 35 cents. ROM, 53 cents. Good kind of stock. That looks like it's a pretty good one. Decent price. We're only throwing one on the board. Good stock. Good availability. So let's kind of take a look here. Doesn't show factory, but it should be fine. Go ahead and grab its footprint symbol and everything else. Get that, blah, blah, blah. Handle up to 60 volts, which is more than fine. Forward current should be more than fine. Switching power supply. The stepper motor should not be pulling more than 2 amps running, even continuously. So we should be fine on that aspect. So let's go to our downloads. Extract that. Bam. And the same as always. We're going to go here. We're going to go back to components. File. Oh, wrong button. File. Import footprint. Bam. Put that there. Now let's see if it's a standard package SMA. Yes, it is. That's a standard IPC package. Good. So I have an SMA package already set up, ready to rock and roll. So if we ever have to throw it into hello, Control V, SMA, components, bam. Now we're going to go here, file, properties. We're going to get our step file. 3D. All right. Looks like it's even got the proper orientation for us on the pad. Sometimes, let's see if we can do this. Yeah. So sometimes parts will use like an engraved line, like a laser engraved line to designate the cathode. In this case, this particular diode, they're using a chamfer right here to indicate the negative, the cathode. And we can double check by going to the data sheet. Never be afraid to look at the data sheets because they will tell you everything you need to know about that particular diode. Cathode band, which is kind of interesting. It doesn't even mention the chamfer here. But it's fine because we know typically that's what it's going to be. So let's go back to our... So actually they're going to use the band in here. That's fine. It's just, again, it's just a step file representation in case we ever want to export the board as a step file with all the components placed. That way it's easy to design an enclosure around it. Because you can import that step file into Fusion or other software, such as SolidWorks, to help design your enclosure around it. It'll be shaped and sized appropriately, and it'll have good general representation of the components so you can get your standoff height, any distances, any clearances you need. So save that. That's the SMA. And then back to the wonderful thing of adding components. So we're going to import the symbol because, for one thing, we don't have a Schottky symbol. KiCad. All right. So we have our Schottky symbol. So I'm going to go ahead and rename it to add diode DS for diode Schottky. It'll just be easier to find in Odo and in here if we have to filter it. I'm gonna go and save it. All right, that's fine. We're gonna go to simple properties, clean all this up. I know I'll be duplicating things, but data sheet. All right, we're gonna fix the footprint, components, SMA diode. Yes, I probably could, name it SMA dash and then the actual dimensional. But SMA is just good enough. Yeah, diode. That's the value. Our internal part number, basically. Description. So let's clean this up here. Boy, better make sure I'm spelling that right because I am again really horrible at spelling. Short-term memory sucks. 60 volts. 2 amp. 2 amp. We can throw the package in here. Doesn't really matter. SMA. Do we need anything else out of here? We're not going to lose much voltage. There's only be a 600 millivolt voltage drop across it. Not going to hurt anything. 75 amp surge current. Let's go in 2 amp. Let's go and do 75 amp surge. That could come valuable information down the line if we ever want to use this diode in something else. Yeah, hardly anything there. Negative 55, 150. Make sure there's no additional certifications that it has that we might want to be interested in. No, perfect. It's Vichet. So we got to go through and add. Number. Go and add the other fields. Low volume cost. Now let's go and get all this stuff copied here. I know it's a lot of duplication. It's a lot of entry, file entry, but if you want to maintain proper inventory and proper control of your processes, this is what it takes. You've got to have all your systems aligned. You have to have your ECAD software, all your parts in there. That way, when it generates the BOM, it aligns with your inventory control, your manufacturing control software. That way, nothing's left to chance. There's no misunderstanding, miscommunication from the beginning of a project to building a material and throwing it up and shipping out the door. It's easier and better to do all this work during this stage as you're developing the project than have to keep going back into and fix everything you're doing. So 36 cents and 0.76. Make sure I got that right. 0.76. All right. Part number. All right. Again, we're going to throw in the val and just leave it empty. That way it's consistent. So there's that. Bum, 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 bum. All right. Products. Here we go. Now copy this guy. Let's go here to Odo. We're going to add a new product. Sales. think I said 036. Yep, 036 for 1. Category. We don't have diodes, do we? Alright, we're going to add this. Diodes, and that's under goods. Reference. And once we get to the point of actually building up our bombs and everything else, you'll see how all this ties together. It will. I guarantee it will all tie together. It all makes sense. Right now, it just seems like, oh, hey, there's all this stuff back and forth, back and forth. Yeah, unfortunately, it's just the way it is. All right. So here, like I said before, we can add a second vendor like DigiKey. It's always a good practice, especially if you're going to send boards out to a fab house company to actually assemble for you. Like if you find you can't keep up with demand, or if you're just happy doing the design, maybe initial prototyping, but you want to put it on somebody else to actually do the manufacturing for you, you want to try to have at minimum of 2 suppliers and maybe even alternative parts if possible. That's why in here I've got manufacturer 1, because this specific Schottky diode being an SMA package, I should be able to find an alternative manufacturer with alternative part numbers. Or here I can, I can throw a vendor 1B, which is DigiKey, have these copied with 1B part number, cost, etc. 1C could be like Newark. Even companies, if you are planning on buying in full reels, which right here it will tell you a full reel is 1800. You could start looking at companies like Arrow, Future Electronics. They specialize in providing larger quantities when you start getting above the hobby or prototype level quantities. When you start getting to larger scale manufacturing, then you might want to look, if you're looking at like buying 5 reels of this capacitor, 10 reels of this resistor, when you start getting in that quantities, you're going to establish a relationship with a company like Arrow, Future Electronics, etc. Because then you can get price breaks, better terms, better conditions on what you're buying. So here's this guy. We've got it added to Odo. All right, she's looking good, looking good. So that'll be our blocking diode. So we're going to save it. Go back to our schematic. Throw this guy in here. Components, DS. Wow, that is a big diode symbol. Wow, there is no mistaking that, fella. Now, before I get too far, let's get this ground here. There's actually something else we could really do if we really wanted to do it. And that is to put a diagnostic LED in here. What we can do is we can find a basic... Oh, crap, I don't need... let's get... Don't tell me I accidentally added... Hopefully I only added... Why is there... Do I have another diode somewhere here? Alright. Okay, well, So we could throw in an LED. I say maybe find a bicolor, like a red-green. So one direction it's green, the other direction it's red. With a current control resistor, like right here before the diode. And we can use that to indicate our polarity. Like, say if it's green, that means your polarity's good. If it's red, your polarity's backwards. But this will be a simple circuit. We will throw a couple indicating diodes in here just for giggles. uh, to indicate power good off of the 3.3 and 5 volt supply, and some test points. So it looks like we're going to be more or less finishing up the power supply circuits before moving too much further ahead and rushing along. So, yeah, I'm not going to worry about putting although it would be kind of cool. But again, now we're coming down to adding more complexity and adding to the cost of the final product. It's a balance. So let's not add the complexity and the costs there. Let's go and get you wired in, you plumbed in. So now we have a blocking diode to help reverse polarity protect. So if you accidentally wire these two guys up backwards, this blocking diode is going to keep it from shorting and destroying anything out, which is perfect. We could throw in a fuse if we really wanted to. I'm not really going to concern myself with that at the moment. I don't really see too much of a need for a fuse, but we'll see. We'll see. So one of the things we want to look at before we get too far ahead, let's close that. Let's kind of minimize our junk here. So let's look at, let's go back to here. Optoelectronics. Let's go to LED indication. Let's see here. Light emitting diodes. So, you want SMT. Let's do 0805 size LEDs. Let's see. Let's do 0805. Bam. So for power, green. Let's just do green. Let's throw green on here. So you got 0805 green LEDs. Let's see. Osram, Broadcom. Let's see. 32 cents. Good stock on that. Osram, 15,022 cents. Good stock on that. 27 cents. Osram. Green chip LED. Good stock on that. 27 cents isn't too bad. I kind of like the way that one looks. A little bit. Let's look at this fella right here. I kind of like that one. 27 cents. Not that big of a deal. Good stock. 14-week lead time, which is okay. So green, maximum forward current. Looks to be 20 milliamps. Just double check. Yep. Oh, wait a minute. Looks like maximum forward current is 25 milliamp. Okay. No big deal. So, you know what? Let's look at this guy. Let's go ahead and download these guys. Bam, bam, bam. Download. And they'll give us an LED symbol. All right. So let's go ahead and all right, extract all. One of these days, I swear I'm going to clean up all these random files and just make it a little bit easier on myself. Just because it's getting a pain in the rear. All right, so okay. So back to KiCad, doing the same thing we've been doing. We're going to go ahead and import the footprint, even though it's an 805. I know LED, but we're going to go to D because technically diode is what it is. LEDs are still usually indicated by the D um, placement. I don't like that dot doing there. Arc. Arc. So what we're going to do is we're going to, on this silk screen, we're going to, where's the line? Hello? Oh, maybe it's over here. Draw lines. Bam. Okay. Alright. So let's make sure 0.8, 2.7. There we go. So that'll be our cathode indicator, which will be pin 1. Alright. And we're going to save this as LED 0805. Components. Bam. Okay. File. Properties. Get rid of that. Add that. Go here. And the same old lather, rinse, repeat that we have to do every time. But it's okay. Alright. Just a block. That's fine. Again, just a representation. Go here to our components. We're going to file. We're going to import a symbol because we don't have the LED symbol in here yet. We probably do. It probably was in one of the existing libraries, but again, I like building from scratch. That way I can control everything in here. Now, alright, so here we go. So what we're going to do is we're going to go and rename this DL for LED, diode LED. Save it. Go in here in the properties. Bam, 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 bam. Get rid of that. Footprint. LED 5. Description. LED. We can put the 572 nanometer in there for green. Let's see if they capitalize it. Probably not. Nanometer. 2.2 volt. Milliamp. That's a maximum forward current. It's diffused. And I think it's top view. If I remember, let's make sure. Yeah, it looks like it's top view. That can make a difference. Because there are side view LEDs. Alright. Negative 30 to positive 85. Negative 30. Sorry about that. Yeah. Anything else that we want to add? Okay, okay. Alright, that's fine. That's okay. And I think it's awesome. Okay. So we're going to Mauser, and then cost 27,049. Now we're going to add another value for LEDs. Color. Green. And we're going to show name. All right. And you know what's next? I'm going to add it to Odo. Information. Code. Category. Technically it's a diode, but we're going to go ahead and add it to LEDs. Again, it makes it easier to search when we're trying to find stuff. This will be description. Go right here. All right, bam. Purchase. Bam, bam. Good to go. Save that. Okay. Save it. Back to our schematic. So we're going to throw that on. We're going to throw two of them in for the 3.3 and the 5 volt supply. So let's go ahead and I don't know if, let me make sure that I've got the right, you know what? Let's clean that up. Reference D. Okay. That's what I want. Yeah. I don't like that one. Alright. Okay. So we're gonna. Now we got to figure out the resistors. So it's not to blind people. I don't want to run it at full. What is the word I'm looking for? Full brightness, 20 milliamps. So let me grab a calculator. A little bit easier for me to have a calculator in here on hand because we're going to do some funky magic. So we want the forward current, let's see, it's 20 milliamps. Let's say that'd be full brightness. So let's just say let's say we want to do half of that. Let's say 10 milliamps. So we're going to do 10 MA. So it'd be about half brightness. We know, it's not going to consume a whole lot of current. 10 milliamps. Diode will illuminate half, but we need to account one for the 3.3 and the 5 volt supply. So we'll ignore. We're basically just going to say we're going to drop a resistor in place because the rules are in a series circuit, the voltage is dropped across the devices, but the current is the same. So we're just going to imagine a resistor in there for now. So we're going to base off of a resistor. So we know we have 3.3 volts. And we know we need 10 milliamps of current. So let's see here. So if we know that, we know our current and our voltage. Our resistance value would be voltage divided by our current. So 3.3 volts divided by 10. It's not going to be very, very powerful resistor. Yeah. Let's see here. 5 volts divided by 3.3 divided by, hold on here, 3.3 divided by 0.01. My bad. That's a 330 ohm resistor. And then the 5 volts, boy, is going to be a 500 ohm resistor. My bad, I forgot to add the decimal place for the milliamps. I was looking at full amps, or 10 amps versus 10 milliamps, which would be 0.01. Yeah, so 3.3 divided by 0.01, 3.3 divided by 0.01, yes, 330 ohms. So let's go see what we can find in an 0603 resistor. Passive components. Resistors. Again, loads of fun. This is the way it goes. Let's see here. 0603. So let's see. 300 is 330 ohms. Plenty of resistors, so it's a common size. So sometimes you'll run into that problem where you'll find a resistance value when you do a search for it. It'll only show like 2 or 3. That means it's not a very common value. So the problem you're going to run into is either one, you could have supply issues, or it's going to be a lot costlier. So sometimes it's better to like bump up the value a little bit to maybe like the nearest whole or the nearest decade, uh, and go from there. So now we're just kind of like looking at like stock quantities and costs. 19 cents Yagio, that's our best cost. Reputable brand, 11 cents Worth. I've used some of their products. I have no problem with using Worth, but I do like Yagio. So we'll go ahead, and the stock quantities that they have in house are better for the Yagio. All right. All right. So what we're going to do now is we don't need the footprint. We just need the symbol. We just need basically add the component. It's a RC. It's going to be an 0603. So we're going to duplicate that, and we're going to rename it and fix it. So RC 0603. So it's 330, 330. What's our voltage? 75 volts, 0.75. What's our tolerance? 1%. So let's go back to here. No, our power rating. So it's going to be 100 milliwatts. My bad. I always get that confused with capacitor. Power rating is 100 milliwatts. So it's going to be the same. Copy that because we're going to need to go in here and I always do the wrong file. Some properties. Put that there. 330 ohm. What was the 1% tolerance? Oh man, that makes life a little bit easier. 55, 155. And is that Q? No, it's not automotive rated, which is fine. Not like we need automotive rated. Yagio. Mauser. Are you kidding me? Oh, I hate that. My stupid gaming mouse and its shortcut buttons. Oh, I need to disable them for things like this. And I 19 cents and 015. And it is 330 ohms. 30 ohms. And then our favorite thing to do is to add it to Odo. But the great thing is, again, we're building up a library. It'll get easier. Systems. You'll find you'll be adding less and less parts to your library as you go along. Doesn't seem like that right now, but we started a library from scratch. First project. Always is like that. First project, first brand new library. Okay, upload it there. Okay, here. Save that. Go back to our schematic. As for the 3.3 volt, it's going to be RC 330. Drag you down a little bit. Hey, stop it. I'm going to copy. All right. Copy this guy. It's kind of, we can shrink these guys a little bit. We don't have to be so far apart, take up so much space. Hello. Them schematically drawn in, that way we don't forget, because it's way too easy to forget. Alright. Alright, so now we got to do the lather, rinse, repeat. Let's go and save this real quick. Control S. Now we need to do the lather, rinse, repeat. Let's keep that guy, do the 330, so we know we need a 500. 26, okay, it might not be too bad. Might not be too bad. Let's see what our costs are. Okay, our costs are a little bit higher. Oh, wait a minute here. Yagio, non-stocked. Okay, all right, so 500 ohm is not a very common value. So what we can do is one, 05. Let's just see. 17. 510 ohms. 321. We could always go down a little bit. All right, that's a lot more comfortable. 22 cents, 18 cents for a ROM. Good stock, 16 cents for a Panasonic. Much better. Better quantities. Yagio, 4,000 in stock. For 500 ohm. Yeah. Okay. We'll just go this direction. Okay, so it's going to be a 510 ohm. It's going to reduce the brightness just a hair. More than likely, it's not going to really be perceptible to us, to you, so I wouldn't worry about it too much. This is kind of weird too because it's showing a 1/5 watt, but it's down here still 1/10. I'll still trust 100 milliwatts. It's fine. Kind of weird. So we need to do the same that we did to the last resistor. We're going to duplicate it and then rename it. 330, so it's going to be I think it's just 500. No, 510. My bad. It's a 510. Oh, what's our voltage? 75 volts, and that is all the same. Get rid of this. Now we're going to go into the properties. 500 ohm. 510. I keep doing that. 1% tolerance. Yep, we're still there. Everything's the same. It's a Yagyu part. And the Mauser part number is this. 10 cents and 021. And it's going to be 500 ohm. 510 again. I got my head stuck on 500 ohm because that's what I calculated out. And then here we go, the lather, rinse, repeat into Odo. That way everything's going to since it doesn't like doing that, we're going to go this way. System alls. Reference. Mauser. Nope, 1 unit. And we're going to save that. Now it's entered in Odo. Okay. I'm going to save this guy. It's a 510. Keep my brain about me. RC 510. Bam. Okay. Hello. There we go. So these will be just some visual indication that the 3.3 volt power supply, and I was an idiot. Good thing I caught that. Drop you down there. All right. Okay. So another thing I'm going to want to add are test points. Back to products. Let's see here. Passive component. Connector. Technically, it's a connector. All right, 5010. Let's see if I'm right, if I remember connector. I wonder if I can do Keystone 5010. Oh, it's red. I want a red one. They make a black one. I mean, red's fine too. Okay, that's fine. Red plastic is fine. 5010. This is a test point I like to use. Even if you don't populate it on the board, it's a through hole part, but it leaves a nice little through hole that you can throw in a wire for like if you need to use external power to supply a board, or if you want to connect to like an oscilloscope to it more permanently, or an external piece of test point. So we're going to go and grab its footprint. Very simple part. I really like it. All right. Let's just go and finish up where we are right now before I finish out for the day. Finish out this video. Let's just go and get this guy done. Now, I do import footprint. That's a connector. I mean, I don't know why we have to have a dot. There's no that kind of confuses me. I'm okay. I'm just kind of blown away a little bit. All right, we're just gonna leave this one as A5010. All right, so we're gonna go back to the components, up to here, connectors. We're gonna import symbol. Let's just go and grab this guy. Not like you really need this guy, but we're going to rename it to, you guessed it, TP, test point. I know, we're getting really original here. All right, footprint. The other connectors, 5010, okay. All right, I think there's a 3D model, but since I don't populate it a lot, depending on what I'm designing, a lot of times I just don't even worry about the 3D model. But you know what? Let's go ahead and do that. You know what? For consistency's sake, let's not play these game file for properties. We're gonna delete that. We're gonna add it. Let's just throw it in there. It ain't gonna hurt anything. Boom. Control S. All right. A file. Properties. Connectors. Okay. Test point. Don't need that. Through hole. Let's see if there are any kind of, let's see here. Nothing really. Nothing huge down here. Okay. Went through a hole. Manufacturer. Keystone. All right. Let's go ahead and add this. All right. 33 cents and a dollar in 180. All right. And we've got to go here. All right. we'll just put that under connectors because that's technically what it is. Mouse on. No, I didn't. My bad. My mistake. Save that. Now we've got that in there. Make sure we're okay here. We're saved. See how that looks on the schematic. Might clean that up later, depending. Might not have to. Alright, so what we're going to do then is we're going to throw 3 of these little guys on here. Okay. No, no. Nope. Nope. Stop it. Stop it. We're going to go. Okay, tie these guys together. Bam. 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 All right. So this should sum up and pretty much finish up the power supply. Schematic. So we have our input power connector, Schottky diode to block reverse voltage protection, power good indicators basically for the 3-volt rail and the 5-volt rail, and 3 test point connections for the 3-volt, 5-volt, and a ground test point just for reference. You always want to throw in at least one ground test point. Sometimes more. We probably will throw more ground test points in for other portions of the board. We'll get to that. We'll cross that bridge when we get there. So we'll clean this up, leave this like this, and we'll pick it up and start catching up and adding some more connectors and test points and stuff for the rest of the things, the rest of the circuits. Thank you for watching, and have a good evening.